We're live! Woohoo! This is elementary algebra, math 40, and we're in chapter 7. Yay! And we're looking at adding fractions, but now we're going to put variables into our fractions. So they're no longer fractions, they get a promotion. Now they're going to be rational expressions. Isn't that fancy? So, but basically, anytime you see the phrase rational expressions, you can just think, oh, okay, these are going to be fractions. It's an expression because there's no guarantee we'll have an equal sign. And rational comes from the word ratio. There we go. So they're fractions. So shall we add some fractions? Woohoo! I'm very excited. Are you very excited? Okay, so the rule for adding fractions is that they need to have common denominators or like denominators. In other words, the denominators have to match. And once they match, they just stay the same. You don't add them, you don't subtract them, you don't do anything to them. The denominator stays the same. Up on top, we add. So I get 5/4, which of course is an improper fraction, but we consider it a fine fraction. Now, if you're doing a word problem, whoops. If you're doing a word problem, it sounds a little weird to say, oh, you should use 5/4 of an apple. So instead, remember what we would do is take 5/4 and we would do 4 into 5 goes once, and we have a remainder of 1, and I'm going to need some handy dandy highlighters. Nothing bad can happen when you've got highlighters. And I end up with 1 1/4. And remember, I know I picked a bad example for this because it's hard to, these are both ones. It's like, well, which one's which? So this one is the whole one right there. And then this one, that's the remainder, is the numerator. And then of course, oh, I'm going to need another color. The denominator here is the denominator here. So hopefully you're noticing, and I'm going to do that here too, because I think that was really a nice way to look at it. I hope you're noticing that the denominators, when we're adding and subtracting and generally talking about fractions, become the thing we're describing. So when I say 3/4 plus 2/4 gives me 5/4, it would be like 3 apples plus 2 apples give me 5 apples. The denominator becomes the quantity you're talking about. So shall we do it? Woohoo! Add or subtract and simplify. So we're going to have to make sure the denominators match. Spoilers, in 7.3, all the denominators match. So 7.3 is just a beautiful section. 27/10 plus 3y over 10. Do the denominators match? Yippee skippy. I don't know where that came from. I think someone made that comment. 27/10 plus 3y over 10 is 27 plus 3y over 10. Now, what you do is we can factor to the numerator. I see a common factor, and I get 9 plus y, right? Factor out the 3, a little bit of practice with our factoring. But is there anything that can cancel? No. So either answer would be correct, and there's even one other form. A lot of people would put the numerator in descending order. So you've got 3 choices. You can factor it, leave it factored, you could leave it multiplied out, you could leave it the way it came, or rewrite it in descending order. Your choice, but ultimately, that's not too bad. That's pretty good. Let's try another one. Okay, we look at the denominators. Do the denominators match? Yes, these are like or common denominators. They're complicated, but they're similar. They're the same. So 10b to the 4th becomes our new denominator, and we just do b cubed minus 8 plus 8. Well, now something interesting is happening, because in this one, there's something to simplify up top because I've got a -8 and a +8. They cancel and I end up with the b cubed. And then I get very excited, as I always do around fractions. Oh my goodness, yay. So what's going to happen here is I've got 3b's multiplied on top. I got 4b's on the bottom. And you can either write them out, 2, 3, because the numbers aren't that big, and then cancel them. Oh my goodness, I'm using all of the manipulatives today. B, 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 B. Oh, B, 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 B. And we end up with 1 over 10b. So now in this case, we did not end up with this common denominator because we could reduce. Okay, shall we keep going? Yes, let's keep going. Do lots of problems. Okay, okay. We'll get there. Again, do we have common denominators? Are these matching denominators? These two denominators match? And the answer is, yeah, they do. They're complicated. Oh, they're a little sideways. These are common denominators. Or like denominators. I don't like the like denominators, but I'm kind of stuck with it because that was decided on, well, probably around the time I was born, in the 15 or 1600s. But I'm not actually sure. So do not cite my fake history. Sometimes I have a bad habit of making up history. Fun fact, no one will question. You could be like, do you know that the first person to invent Jello was actually living in southwestern Brazil in the 1308, and there was an ice cream shortage, and that's where they came up with Jello. And in fact, the first flavor of Jello was passion fruit Jello. Now, see, that was all completely made up out of my head just now, but if you said that convincingly, people would believe you. So, 1308, let's start convincing everyone. That's when Jello started. Okay. H squared minus 4h minus 5. The great thing about math is you can't make it up because it just is. I add the numerators. The denominator stays the same. Blow. Now I look at this and I sigh. Why am I going to sigh? Why did I give myself so much room? You should always be worried when I give myself a lot of room. It's like, wait a minute, you never give yourself enough room. What's going on here? And the answer is, well, the 1 plus h rewritten is h plus 1. And suddenly I'm looking at this going, oh no, I bet this factors. So let's see. I got h plus 1 on top. Leave that alone. And now down here, I've got h squared. So I'm going to approach it with trial and error. You could use the AC test method. I need two numbers that multiply to -5 and add to -4. What if I had h minus 5, h plus 1? Let's check it. H times h is h squared. 1h minus 5h is -4h, and -5 times 1, -5. Okay, the FOIL works out. Notice this whole thing can cancel with that whole thing. So here's the thing. If you were to type this into WebAssign or turn this in for homework, it would bounce it. It would say, no, it's not correct. And the reason for that is you're going to have to reduce all of your rational expressions now. Now that they got a fancy new name, they're all uppity and they're like, oh, you need to cancel me now. You need to reduce me. If it helps, you can make exploding noises. You could scream. You could draw fire. I mean, I've been known to draw fire on math that I don't like, right? Set it on fire. Fire. Some yellow. Fire always looks best with yellow. Let's see, we can get the smearing going on. This will confuse the heck out of anyone who doesn't watch the videos and is just looking at the notes going, why is this one on fire? So there, you can put it on fire if you want. It's your homework, it's your notes. And if you want it to be on fire, it's on fire. You can just sit here, bask in the glow. Yay. Okay, so next page. Woohoo, one more problem. Oh no, why would there be one more problem with a whole page of space? I don't know. Don't worry about it. It's not that bad. Okay, so again, I've got t all over. Let's take a good look at this. I see t squared plus t minus 2. I think in both cases, they do match. So we've got common denominators. T squared plus t minus 2 minus 1 over t squared plus t minus 2. And that gives me, and then I'm subtracting. So across the top, I subtract. Across the bottom, it's exactly the same, right? The same denominator. Won't you take me to Smearyland? Won't you take me to Smearyland? There you go. Don't let it be said that math teachers have no soul. Well, I don't, but in general, I don't. I don't actually know what the deal was the rest of them made, but yeah, I was like, yeah, I'm not using this soul, so I might as well. Fame and fortune of a math teacher? Yeah, sign me up. Okay, so t squared plus t minus 2. I am not just suggesting that all of your math teachers made a deal with the devil, but let's be honest, this does seem kind of wicked, doesn't it? All these letters and numbers running around. Yeah, I know. You've suspected it, I'm sure. Well, I'm here to say it may be true. It might be true. T squared plus t minus 2 minus all the smears. I know it's hard to see. Sorry about that. I got excited about, anyway, you know me and my highlighter issues. So I'm going to break this guy up, see if I can factor it. I got t squared, so that gives me a t and a t. I've got a minus 2 here, so I need two numbers that multiply to give me negative 2. And then here, I need those same numbers to add to give me 1. So let's see. What about 2 and negative 2? Without, or sorry, 2 and negative 1. So sorry. 2 times negative 1 is negative 2. 2 plus negative 1 is 1. Okay, that works. So this is plus 2 and this is minus 1, which is perfect because that's what we needed to cancel. And again, if you want to draw explosions or fire or whatever, these are just numbers. You can't hurt them. They're totally cool with it. They probably feel a little bit of guilt about making your life so hard. I would. So, woohoo, that's 7.3. Add, subtract, reduce is what I have up over my fireplace instead of live, laugh, love. Add, subtract, reduce. It's truer words were never spoken. Have a good one, guys. Math on.